we'll see. I don't know if we'll do all of these, but we'll get through a good chunk of them here.
Is this the same thing we were doing, Scott?
What?
Is this maybe the same thing like we were
It's similar, yeah. It's in the same section, right? So this is the next piece of it. Okay. It's not like I'm making it any harder. I'm just moving on to the next piece. And that gives us a little bit more time in class to do something different tomorrow. Okay. All right, we ready? So this one is, how do you know that you have a limit that is approaching infinity? Okay, we're probably going to look more analytically in this section than with the last one we did graphically and numerically. Okay, and we looked at some asymptotes. So we're going to keep going with our asymptotes. It says determine where the vertical asymptotes or removal discontinuities are for the graph. We've actually done this already. It just didn't have those instructions. So we probably want to factor. So let's factor that first. Okay, you tell me, what does the numerator factor into? Do we agree with -4 and +2? I like +4 and -2 a little bit better. Okay. Good numbers. You just got to watch your signs. Okay, what's the denominator factor into? Good. All right, so remember, when it cancels, it's a what? A whole. Is that removable or non-removable? Removable. And remember, to get the value of the whole, we set it equal to 0. So where's my whole at? At 2. Okay, so we know that it's a removable discontinuity at x equals 2. And it's because it's a whole. Okay, because it canceled. All right. So my official function now is x plus 4 over x plus 2. How do I get a vertical asymptote? Set the denominator equal to 0. So where's my vertical asymptote at? -2. So we know that, is a vertical asymptote removable or non-removable? Non-removable, but this one doesn't ask about that. It just says vertical asymptotes, right? So we would say vertical asymptote at x equals -2. So these are the two things they're looking for the answer. And that's why I had to do the Khan Academy thing, because it does a really good job of giving you a bunch of problems on this stuff. I really liked what they were doing with it, so thought it would be good practice. Okay, so that one was just vertical, and that was kind of review. Now they want us to find the limit. Okay, so I'm going to give. So on this one, we have to decide if it's going to infinity or negative infinity, basically, when we're seeing this one. So can I just direct substitute the 1 in there? Yeah, and there's nothing that's going to factor out of the top that's going to be able to cancel, right? My denominator. So what I have to do is I have to kind of approach the -1, okay? Or sorry, the 1 from the left side, correct? So what I'm going to do is I'm going to start by plugging in a 0. Okay, so I'm going to plug in 0. So I'm going to do 0 squared minus 3 times 0 over 0 minus 1. And I'll show you where I got the 0 from in a minute. Let's plug in two numbers and then I'll talk about them. Okay? All right, so when I plug in 0 into the top, what do I get there?
1.
0 over -1, which is 0. Okay, so let's talk about what's actually going on here. I know it's some kind of rational thing. I know there's a big hole at x equals 1, right, somewhere. I don't really know where that is, but somewhere there's a hole. I know that there is a point at 0, 0 on the graph, right? Because that's where this is going towards. And remember, I'm trying to come at it from the left side and see what's going on there. So it might not be a hole. It's probably an asymptote, right? Not a hole, because I didn't cancel anything. So ignore my hole. Okay. All right. So I also want to see. So I need to know if from here if it's going up at that value or coming down. Okay. I can't really get any closer other than plugging in maybe a 0.5, which I really don't want to do. So I'm going to go the other direction. I'm going to plug in a -1 now. Okay, and you'll see why here in a second. So let's plug in the -1 and see what we get. All right, what's -1 squared? 1 times, or so -3 times -1 is 3 all over -2 So 4 over negative 2 is going to be negative 2. So I know I've got a point at negative 1, negative 2. So now, do you see how you can kind of start sketching that graph? So we know that it's not, we know that there's an asymptote there. We just need to know which direction it's going. So by plopping in a couple of points and being able to at least kind of sketch the direction that those points are going, am I going towards positive infinity or negative infinity? Positive infinity. Okay? All right, let's try one of those again. Yeah.
Did you purpose? No, not purpose. Why'd you say there's for sure a point at 0, 0?
Because what I did was I evaluated the function at 0 here. Right? I took the function and I plopped as x value of 0 in and I got a y value of 0 out. Okay? This one here, I took the function, I plopped in a negative 1, right? And I put in an x value of negative 1, got out a y value of negative 2. All right, we good? All right, let's try it again. All right, so I've got I've got 1 again. So what numbers? Oh, I'm coming at it from which direction this time? The right. So if I'm at 1 from the right, if I'm trying to come at it from the right side, what numbers do you think I should plop in? 2 and 3. Perfect. Okay, so if I'm going to plug in a 2, so this is really going to be f of 2 equals 2 plus 2 over 1 minus 2. What's 2 plus 2? 4 over negative 1, which is... And you guys, it really helps me to plop the dot on the graph, okay? Because I can kind of see the direction then. So 2, negative 4. Sometimes I'm a more visual person. I need to see it, okay? All right, what other number am I going to plop in? 3. So we've got 2 plus 3 over 1 minus 3. What's 2 plus 3? 5 over negative 2, which is really, isn't that 2 goes into 5 how many times? So negative 2.5 about, right? So we've got 3, negative 2.5-ish. So if I have to come in towards the 1, where is that graph going? To positive infinity or negative infinity? Negative infinity. Does it make sense now a little bit better? I know I didn't explain it well on the first one there. Are we okay? Kind of. All right. So let me explain one more time off of this one. I decide left or right to begin with, okay? And it's easier if you just sketch a little bit of the graph. I know that I'm coming in towards the 1. I know I've got to pick values to the right of it, okay? And then I examine what's happening with those y values to the right of it. So as I'm coming in towards the right, is it pointing down or is it pointing up? And again, it's good to sketch where those points are. It helps you visualize it, okay? All right, let's look at this one. This one, I believe, factors a little bit. So what I want you to do is take a minute and go ahead and factor it for me. So everybody's factoring on your own right now. Magic X in boxes, maybe. Okay, so take a minute and factor. All right, what do we get for the top? What are we thinking? 2x plus 1 I like. Good. 2x plus 1, 3x minus 1. Okay, watch your signs. Make sure your signs are coming out correctly. Okay. What about the denominator? What'd you get? We don't have it yet? 2x minus 3, I like that. What'd you get for the other part? 2x plus 1. Okay. If we're having factoring issues, that's a whole nother story. Okay? And I know those that came out of my class versus those that came out of Rondeau's class, we do it different ways. We all start with the magic X, but from there we're different. So you're coming out of Rondeau's class, you got to ask somebody who came out of her class. Okay? Or I'll teach it to you my way if you really want to learn it my way. All right, so what happens now? We're canceling, and when we cancel, we end up having a hole. Technically, that hole, we don't really need this, but let's look at it for a second. Our hole is at -1/2, isn't it? Isn't that what we're approaching? Yeah, so we need to know what's happening on which side of it. The right side of it, okay? But on this one, now that I've done that, and technically my limits should still be out front there. So we still have the limit as x is approaching -1/2 from the right. Am I able to direct substitute on this one? Would my denominator go to 0 if I direct substitute? No, so I can direct substitute on this one and it's okay. It's because it's a hole, not an asymptote. Okay, if it was an asymptote, we have to do what we did in the last two examples. So we've got 3 times -1/2 minus 1 over 2 times -1/2 minus 3. All right, so what's 3 times -1/2? -3/2, right? I'm going to work smart and not hard on this one here. I'm going to go turn that into 2/2. What happens with these 2's? Cancel, so I've got -1 and -3 is what? -4. We keep kind of going up here. Let's see, what's -3/2 and -2/2? -5/2 divided by -4 over 1. Notice I put the over 1 there. Huh? Probably, yes. Sorry, right? Do I need more space in there? Okay, I'll write that down for next year, hopefully. All right, I need to flip and multiply this one. We're almost done. This is the last little bit. -5/2 times -1/4 would be 5 over what? 8. So the limit is 5/8 on this one. Okay. All right, let's do one more, and then we're going to call it good, and we'll finish up the last 3 examples tomorrow, okay? So, on this one here, I'm going to rewrite it, okay? Because I know that the cotangent, so cotangent is cosine over sine, right? And if I put the cosine of 1 over the sine of 0, I would get something undefined. So I can't put that in there. However, I know that 1 over cotangent is the same as tangent, isn't it? Oh, right, get your limit in there. Limit as x approaches 0. Can I direct substitute it now? Sure. So I'm going to put in 0 plus 2 times the tangent of 0. All right, 0 plus 2 is 2. Tangent of 0 would be 0 divided by 1, which is just what? 0. So 2 times 0 is 0. All right, so we'll save the last 3 for tomorrow, okay? So the homework only has to do with the first half of the lesson today, okay? So let's go look at... Yes. 3 pi over 4 is right here, and it was secant. It would be, I think you maybe got it right. I marked it wrong. Because secant is the reciprocal of that, right?
Yeah.
Which would be square root, it would be 2 over square root of 2. Yeah, you got it right. I don't know why I marked it wrong. That was my fault. Still didn't get 100, but you're right on that one. Thank you for asking. Okay, we ready? Let me grab my file here. Okay, let's talk about limits, okay? So, basically what this theorem is telling us,
No, don't.
all right.
Only get Brian gets
Okay, here we go. You ready? You're listening. So, they're saying C and L are numbers, okay? F and G are functions. So that's what the first line says right there. Okay, again, I always go through these because somewhere along the lines you may have to read one on your own someday. Okay, so it's good to understand how to read it. It's saying that the limit of the function f is infinity and the limit of the function g is L, meaning a number, like 3. Okay? When we go ahead and we add the two limits together, so basically, let's pretend that L is a 3 right now. If I add infinity plus 3, I still get infinity. Does that make sense? So when I add two together, where one of the limits is infinity, the limit is infinity. Okay? If I am multiplying them together, I would have infinity times maybe 3, that's still infinity. But if I had infinity times negative 3, that would be negative infinity. So they're basically saying here, remember that when L is positive, you're going to go to positive infinity. When L is negative, you'd go to negative infinity. Okay? The quotient is saying, so this one's interesting. It's, notice, the L is on the top and the infinity is on the bottom. So let's think about that. If I had 3 and I'm dividing it by infinity, I'm taking a small number and dividing it by a giant number, isn't that basically going to 0? Okay, and that's how I want you to think about it this year, is when you have something small on the top and something giant on the bottom, it goes to 0. Okay? If I had something giant on the top and something small on the bottom, it would go to infinity. Okay? So, that's how you got to think about things. Alright, so let's go ahead and take a look at this, okay, and see what these last 3 examples are about here. So, I've got the limit as x approaches 0. So I'm going to go ahead and split that up into 2 separate functions. So I've got the limit as x approaches 0 of 1 plus the limit as x approaches 0 of 1 over x squared. Okay. All right. So what's the limit of this first chunk right here? It has to be 1, right? No matter what I plug in there, I still get a 1. Okay? Unfortunately, I can't plug the 0 into this thing. Okay? So here's what I want you to do. Okay? Let's go ahead and graph it. So put this in your calculator. Okay? We're going to use the tools that we've got. Put it in your calculator right now. So 1 over x squared, get a picture of it. And then we'll talk about how I might do this again analytically. Okay? Okay, so I really kind of need to know what's going on both sides. Does it look like this thing? Yeah? Okay. So if I was going to do this without my calculator, could I put in some numbers? Could I put in 2 and 1 and read what is going on? If I put in a 2, we would say that that would be 1/4, right? If I put in a 1, don't I get a 1? So we know that the number keeps getting bigger and bigger and bigger, so we know that it's going up towards infinity. Over here, I would do the same thing, but I put in -1 and 1. Or sorry. -2 and -1. If I put in the -2, I still get 1/4. If I put in the -1, I get 1. So again, it's going up towards infinity. So since it's approaching the same thing for both sides, what would that limit be? This would just be infinity, right, for that chunk. And now I have 1 plus infinity, which is what? Infinity. Okay? So, again, right now, when you're doing your homework, if you need to put the picture in, use your calculator. That's okay. All right? And we would make sure on the test that we aren't, I mean, you should know that you can plug in on maybe one of them, but if you don't have the calculator, but you make sure you use all the tools you got. Okay? All right. That one's uglier, isn't it? Okay, so I'm going to do the limit of the top and the limit of the bottom. So, and notice we're only approaching from one side, so it looks like a right-handed limit. So the limit as x approaches 1, I'm sorry, left-handed is a minus sign, right? Yeah, limit as x approaches 1 from the left of x squared plus 1 over the limit as x approaches 1 from the left of the cotangent of pi x. Okay. All right, so let's talk, the numerator one, I can use a direct substitution. Doesn't matter right or left. I can plug in. It's not going to give me any funky denominator anywhere. So in this top one, when I plug in a 1, what do we end up with? 2. And notice I'm leaving space for my denominator to work on that. Okay? All right, so for the bottom, I've got to figure out what I am doing for the picture. Okay? Probably what I'm going to have you do is go ahead and put that in your calculator. Make sure you put in the cotangent of pi x. All right, so is the picture looking something like this? Oh, wrong. Is it looking like that? Yeah? Okay. There's a lot of them probably, right? But we only are concerned with on the, we're only, oh, I'm on the wrong side of this axis, aren't I? Let me fix that. Because it's supposed to be going to 1, isn't it? So is it something, is the axis here? Or here? There? Okay, so and there's like a line there? Okay, so that's probably your 1 line, all right? So where is that limit approaching? Negative infinity. Okay, again, I could take and I put in, if I was getting close to 1, I could put in cotangent of pi times 0. I could put in cotangent of pi times 1/2 and see what's happening. Cotangent of, so that's basically cotangent of 0. 0 is the sine over the, sorry, the cosine over the sine. That was ended up undefined. I picked a bad number, didn't I? All right, if I put in 1/2, my guess is I probably, so pi over 2 is what that one is, right? That's up here, isn't it? Yeah. What do I end up with? Oops, other way around, doesn't it? No, it's that way. The cosine over the sine would be 0, wouldn't it? So that didn't really help me. I'd probably also have to maybe put in cotangent of, what's after 1/2? 1/3? 2/3? I'd have to put that in as well. So cotangent of 2/3 would be over here, isn't it? Square root of 2 over 2, it's going to be negative, or no, it's not square root of 2 over 2. It's 1/2, isn't it? Negative 1/2. So see how the negative 1/2 came up? Or it's actually not negative 1/2. It'd be negative this, wouldn't it? Yes, it's cotangent, not cosine. Right? So square root of 3 over 2. Cotangent is the cosine over the sine. Yeah, so, but anyways, I'm going from a 0 to a negative, so then you see that you're going down. And the reason I'm showing that is what if you don't have your calculator for the picture, right? You have to be able to plug in, pick some numbers and plug them in and see what the trend is, okay? All right, so 0 over negative, or sorry, 2 over negative infinity is going to end up being what? 0. Good. Okay, last one. So we've got to look, we're looking like we're approaching it from the left. Notice, I don't have any, it doesn't appear to have anything going on. Let's try tearing that apart for multiplication. So the limit as x approaches 0 from the right of 3 times the limit as x approaches 0 from the right of the cotangent of x. Okay? So what's the limit for this first chunk of it? 3. All right, and we just did cotangent, didn't we? We just did it from the other direction. You still have the picture in your calculator almost, don't you? Yeah, so cotangent, it's going to, as we're approaching 0, where is it going to? Positive infinity. And so 3 times infinity is infinity. Okay, I don't think I've put up. So go ahead and open Haiku. I'm going to put up the assignment. I hadn't put that up yet, but I will right now. Oh, I have the wrong date on it. Let me put the right date on it.